Ever pondered why data analysis is so vital in today's world? It's like being the detective of the digital age, sifting through mountains of information to uncover the hidden truths that lie beneath. Data analysis is the key that unlocks the door to understanding our increasingly complex world. Across a multitude of fields, from business to healthcare, government to science, data analysis plays a crucial role. It empowers us to make informed decisions, guiding our actions based on concrete evidence rather than gut feelings or guesswork. Imagine being able to accurately predict trends, foreseeing the rise and fall of markets, or the spread of a disease. Think about the power of having valuable insights at your fingertips. Insights that could lead to breakthroughs in technology, medicine, or social policy. These are not just dreams, they are the realities made possible through data analysis. In essence, data analysis is the backbone of informed decision-making in every field you can think of. So where do we start? With data exploration. This is where our journey into data analysis kicks off. It's akin to being an explorer, charting unknown territories. We delve into our dataset, seeking to understand its structure, trends, and characteristics. It's like taking a magnifying glass to our data and getting up close and personal with it. We investigate each variable, its type, and how it's distributed. We look for patterns, relationships, and anomalies. We might also identify the missing values and outliers that could potentially skew our analysis if left unchecked. This exploratory stage is crucial. It sets the stage for all the subsequent steps in our data analysis process. It's our first brush with the raw data, helping us get a sense of what we're working with. It's like reading the blurb of a book before diving into its chapters. After data exploration, we have a good understanding of what our data contains. We're ready to move on to the next phase, data pre-processing. Next, we dive into data pre-processing. This crucial step involves cleaning and formatting the raw data to make it fit for analysis. Imagine you're an archaeologist. The data is your artifact, but it's covered in dirt and debris. You need to clean it up before you can truly understand what you're looking at. Now, let's talk about missing data. It's like an incomplete puzzle. You can't make a full picture if pieces are missing, right? So we use specific techniques to fill in those gaps, ensuring we have a complete data set to work with. Then we have outliers. These are data points that are significantly different from others. They're like that one weird cousin at a family reunion. While they can provide interesting insights, they can also skew your analysis. So we deal with them appropriately. Lastly, we have normalization. This is like translating different languages into one. It brings different scales of data down to a common scale without distorting the differences in ranges of values. With data pre-processing, our data is now ready for analysis. Now we can perform descriptive statistical analysis. This process is like a detective's first look at a new case file. It involves the use of summary statistics and visualizations to describe the main features and trends in the data. It's our first step in understanding the story the data wants to tell us. Let's imagine we have a data set. It could be anything from population census data to a company's sales records. Our first task is to identify the central tendencies of the data. We look at measures such as mean, median, and mode to understand what's typical in our data set. Next, we examine the spread of the data by calculating variance, standard deviation, and range. This helps us understand how much our data varies from the average. Finally, we may create visualizations like histograms, bar charts, or scatter plots to better understand the patterns and trends in our data. Descriptive statistical analysis gives us a summary of our data. It's a vital step in turning raw numbers into meaningful insights. Ready to dive deeper? Let's explore advanced analysis techniques. First up, we have time series analysis. This is where we examine data that's been collected over a period of time to identify patterns, seasonality, and trends. For instance, a company might use this technique to forecast sales, or a meteorologist might use it to predict weather patterns. The goal, to anticipate the future and make informed decisions. Next, we delve into regression analysis. This is a statistical method that allows us to study the relationship between variables. Think of it as a way to predict a value based on other independent variables. For example, a real estate agent might use regression analysis to determine the selling price of a house based on factors like its size, location, and age. Moving on, we have cluster analysis. This technique is all about identifying natural groups or segments within a data set. Imagine a marketing team trying to segment their audience for a targeted campaign. Cluster analysis could help them identify groups based on shared characteristics like age, purchasing habits, or interests. Then, there's association analysis. This is where we identify frequent relationships and patterns among variables. It's often used in data mining and recommendations. To put it into perspective, think about the customers who bought this also bought recommendations you see when shopping online. That's association analysis in action. Finally, we reach the realm of machine learning. This is where we use algorithms to create predictive and classification models from data. Machine learning can help us predict customer behavior, detect fraudulent transactions, or even diagnose diseases. It's like having a personal assistant who learns from experience. With these techniques, we can extract even more insights from our data. But how do we communicate these insights? Through data. Data visualization is the art and science of turning data into a visual story. It's about painting a picture with numbers, making complex data digestible, relatable, and above all, meaningful. Imagine trying to understand a dataset with thousands of rows and columns. It's overwhelming, right? But when this data is transformed into a graph, a chart, or an interactive dashboard, it becomes accessible. Trends jump out, patterns emerge, and suddenly you're not just looking at numbers, you're seeing a story unfold. Graphs and visual representations are powerful tools in the data analyst's toolbox. They help us to effectively communicate insights, making them accessible to everyone, regardless of their data literacy. From pie charts to heat maps, scatter plots to histograms, each visualization technique serves a unique purpose, helping to bring different types of data to life. Data visualization makes our insights understandable and impactful. Finally, we must always consider data ethics and privacy. This aspect of data analysis is as vital as the rest, if not more. When we talk about data ethics, we're referring to the moral principles that guide our conduct in the collection, storage, and analysis of data. It's about ensuring fairness, respect, and transparency. Picture this: you're given a data set. You're excited, ready to dive in and uncover all the patterns and insights it holds. But before you do, you need to ask, where did this data come from? Was it collected in a fair and transparent manner? These are ethical considerations. Privacy, on the other hand, is about safeguarding personal information within the data. It's about making sure that sensitive data like names, addresses, or health information aren't exploited, and that the data subject's rights are respected. Now, you might be thinking, I'm just analyzing the data, I didn't collect it. But remember, as a data scientist, you are part of the data lifecycle. You have a responsibility to ensure that the data you work with is ethically sourced and handled. This leads us to data protection regulations. You've probably heard of laws like the General Data Protection Regulation in Europe or the California Consumer Privacy Act. These laws set standards for data collection, storage, and use, and are designed to protect individuals' privacy rights. Non-compliance can lead to hefty fines and, more importantly, loss of trust. So, when you're working with data, always keep these regulations in mind. Make sure you're compliant. Use anonymization techniques when handling sensitive data. Be transparent about your methods. And most importantly, respect the rights of the individuals behind the data. Remember, with great data comes great responsibility. Always consider ethics and privacy in data analysis. So that's our journey through data analysis. Exciting, isn't it? We've navigated through the pivotal stages of data analysis, from the crucial initial step of data exploration, where we delve into data sets to understand their structure, trends, and characteristics, to the essential process of data pre-processing, which involves cleaning and formatting raw data for analysis. We've also taken you through the importance of descriptive statistical analysis, which uses summary statistics and visualizations to describe the main features and trends in the data. We've highlighted the significance of advanced analysis techniques, such as time series analysis, regression analysis, cluster analysis, and association analysis, and how they can help you make sense of complex data. We've showcased how machine learning algorithms can create predictive and classification models, and the power of effectively communicating insights through data visualization. Lastly, we've underscored the importance of data ethics and privacy in data analysis. Data analysis is a powerful tool. Use it wisely, and the insights you can gain are limitless. Until next time, keep exploring, keep analyzing.